Welcome to the presentation on vectors. The aim of this is just to give you a brief definition of what a vector is and then show you how to add them graphically. Okay, a vector is just anything that has both magnitude and direction. If you were talking about a force, then you'd draw the force as an arrow. The length of the arrow would represent the magnitude, so the longer the arrow, the bigger the force. And the direction of the arrow, so like that would be the angle at the arrow to the horizontal, that could define its direction, or maybe you could even say it's northwest or north-south, if you're, depending on where you're looking at the force from, would tell you the direction. Yeah, bigger arrows would be bigger forces. And it's not just forces that we're talking about, it could be anything. It could be velocity, it could be displacement, it could be momentum. Quite a few things fall into the vectors category. Anything with magnitude and direction. Okay, the reason why I'm doing this presentation is so that you can answer questions like this that come up in the IGCSE exam. The basics of this question, you can pause the video and read the question, but the basics of the question are, they tell you the force acting here, pulling straight down here, and the force pulling straight down here, and they want you to be able to calculate what this must be if this whole setup is in equilibrium. Equilibrium meaning balanced forces, there's no acceleration either up or down or any way whatsoever. So I'm now going to just pass over to a video so that that's clearer to understand.
Okay, so what we've got here is a setup to analyse vectors. Now, two pulleys that spin freely and a piece of string in between. You might not be able to see the string, maybe I can show you now. You can see the string there. If my hand weights from either side, I can start to show you a bit of a demonstration. Right, there is 500 grams here and 400 grams here. 500 grams is 0.5 kilograms multiplied by the acceleration due to gravity, which is 10, this is 5 newtons, and this is 400 grams or 4 newtons in the Earth's gravitational field. Right now, you can see that this is not balanced. We don't have equilibrium. This is because there is a net force acting in this direction. And you get acceleration when they're released. Of course, when this is now touching the floor, some of that force is being supported by the floor. Okay, I can change this setup and add another weight to the centre, and we achieve equilibrium. If I didn't know what this mass was, I could go about calculating the force due to this mass by looking at the angles here and knowing the forces being supplied here and here. Okay, so we have, I think it was 5 on this side. So you'd have 5 Newton this way, 4 Newtons this way, and if you sum those vectors, we should find that it's the same as this here. That's what we're going to do now. Just to quick, for a bit of reference, just to look at the setup one more time. Okay.
Okay, so now you've seen that, let's just zoom in on this picture and zoom in a bit more, and I've just gone over the lines with white so it's clearer on this video. Right, the first thing you need to do is choose a scale for your vectors you're going to draw. On my screen here I've decided to use 1 centimeter for 1 Newton as it will fit on the screen. If I did it any larger I wouldn't be able to fit it on the screen. If I did it any smaller it'd be very difficult to do and I'd have inaccurate results. So once I've chosen a scale, I draw the vectors on, step 1. Step 2, measure the angle of the vector you decide to move in relation to the other vector. This is the easiest way of doing it. I'll stick my protractor on here, measure the angle between here and here, and then I know I know this vector's direction then as well as its size, so I can then go about moving it. So that's step 2, measure the angle. Step 3, after you've measured the angle, is to add the vectors, which just means literally to move this vector to here, Okay, so I've moved it to there. That's step 3. That's what adding a vector means. It means moving one vector. You could do it either way. You could have moved this vector here, or you could have moved the vector I have moved. What we say is we add vectors tail to tip. So we take the non-arrowhead of one vector and stick it on the arrowhead of the other vector, but keep the angles all the same. Okay. Finally, step 4 is to draw the resultant vector. The resultant vector is from the start of the first vector, so over here, to the end of the last vector, over here. You then go ahead and measure its length, and then step 5, you use the scale that you've already written down from the beginning. So I used 1 centimeter for 1 Newton to calculate the magnitude of your final answer. Okay, so my final answer is it's a force of 7 newtons acting directly down, because this vector and this vector both add up to this green vector. Okay, hopefully that's helped you. If you have any questions or comments, please make a comment on the YouTube video. Thank you very much.